Okay, so questions, I'm going to go in order. So questions on 4.2, this was your right triangle, no, this is your unit circle, sorry. So this was using the points to find either the coordinate point, using a triangle, use the coordinate point, or using the actual coordinate point on your unit circle to find your trig functions. Anybody get stuck on anything in 4.2? We're good on 10, yes. We're good on the point for 16. So I'll post this, but this is already on an announcement that I sent out yesterday. Everybody's good? Yes. Get them all on the same screen. Yep. Okay. So your test, remember your test is a week from yesterday. So it's Tuesday of next week. They'll be divided into calculator and non-calculator parts. You do need a calculator, okay? A lot of the right triangle trig stuff from like 4.3 required calculator. Most stuff from 4.2 I would say is unit circle based, so there's not a lot of calculator parts on there. I will give you back your unit circle quiz once they're all taken. Once all those lovely names disappear from my board, I'll give them back to you. And you'll get them briefly just to look at them and make any corrections, and then I'm going to collect them back from you again and give them back to you on test day. Okay, again, teenagers can't be trusted, especially you people. Liars and cheaters. Just kidding. Not you guys. It's all my other classes I'm worried about. All right, how about 4.3? 4.3 was your right triangle trig. Questions on these. So this is where you had to find missing side lengths if you were given a triangle, and then from there, sine and cosine and tangent. Mm-hmm. Okay, 56. So this time it gave you the secant of theta was 5 over 1. Move these out of the way. So that means your hypotenuse over your adjacent side would be 5. Or say they gave it to you as 5, so it would be 5 over 1. So that would be 5. Hypotenuse would be 5. Adjacent side would be 1. And then it actually gave you the tangent, but you didn't even really need it. Okay, eventually we would need that if we wanted to figure out what the positive and negative sign was, but not so far because these were just regular right triangles. So if I did 5 and 1 and used the Pythagorean Theorem, I would have gotten 25 minus 1, which is 24. Square root it, and you end up with 2 root 6, which actually goes into that opposite side. And then the tangent kind of just confirms it. Tangent would be opposite over adjacent, which would have been that 2 root 6 over 1. And then from there, cosine is 1/5, cotangent root 6 over 12. Cotangent of 90 minus theta. Remember, these are your cofunctions. Cotangent goes with tangent. And because this is a right triangle, the complement would be the opposite angle. So instead of looking at theta here, I'd be looking at this angle here. And the cotangent to that would be the adjacent over the opposite side, or 2 root 6 over 1. And then sine of theta, go back to your original angle, opposite over hypotenuse, which is 2 root 6 over 5. Any other questions from 4.3? So that's that one. We're good. Christian? 73. So the actual problem said, what, tangent of 30, right? Oh, you had to set up is this a word problem?
No.
Had to give you a triangle though, right?
Yeah.
So you had a triangle, you had 30 degrees, this is 90. And what side did you have? The adjacent side?
Yeah.
Did you have anything opposite 90?
No, just R and Y.
Okay, so this is the only reason you can do this is because this is a special right triangle. If it wasn't 30, 60, or 45, you'd have to get given 2 side lengths. But because it's a special right triangle, the relationship between the 30, 60, 90, the opposite the 30 would be x, let's just call it. Opposite the 60 is x root 3, and opposite the 90 is 2a, or 2x. Let's keep the variables there. So when I go to, oh, I lost my triangle. When I go to solve for the missing side, because it asks for a tangent, right? I need x. So 105 would equal x.
It said to find the 2 lengths. It didn't ask for tangent.
Oh, okay, but I can set it up that way. So I can use that 105 equals x root 3 to solve for x, which is going to be the side opposite 30. So I would divide both sides by root 3. And then I get 105 over root 3, and then I have to rationalize it. and I get 105 root 3 over 3, and 105 is divisible by 3. It's 35 root 3. So that's this side. And then this side would be 2 times that, or 70 root 3. So the way that they set it up was using almost like your trig functions with the triangle. I think it's way easier to use your special angles, because that's definitely something that you're going to see in standardized tests, so you want to make sure you remember those ratios. 4, 4. So now we're dealing with some more right triangle trig, but of any angle. So sometimes these were on your unit circle, sometimes they were coterminal. So we're good on that one. I'll move this one over here. 24 was quadrant 5. 34, you had to use the quadrant angle. Nicole. Could you go over to 64? Sure. 48, 60, 64. Okay. So 64 is asking for the reference angle of 17 pi over 7, right? So remember that most of them, like a lot of the special angles, you just do pi over the bottom. But when it's different from one of your special angles, in this case 17 pi over 7, I would have to convert that 17 pi over 7 into a mixed number. And I end up with 2 and 3 pi over 7. So then from there, I know the 2 puts me all the way on the right-hand side. So I'd end up going all the way around to 2. And then 3/7, I have to figure out if that's bigger than a half so that it passes the y-axis, or if it's less than a half so it stays in that first quadrant. Because 3.5 would be half of 7, I know it's less than it, which keeps you in the first quadrant. So this 3 pi over 7 would actually be the reference angle because it is in the first quadrant. If I had gone past the half mark, let's say it was 4 pi over 7, when I converted it, then I would take and subtract that from pi, because in that second quadrant we subtract from pi. Okay, so 80 gave you that the cotangent of theta is negative 3 over 1. So the actual suggestion is to use the Pythagorean identities, but because we haven't done them, I wouldn't even go there yet, which is what that work is. I would totally ignore that work, okay? And I would use my triangle. So if it's cotangent, then I would put theta in a corner. I'd draw my triangle, put theta in the corner. And then that means if it's negative 3, it'd be negative 3 over 1. Cotangent would be adjacent over opposite. So the side next to theta would be the negative 3. Opposite theta would be the 1. And then I would use Pythagorean Theorem to find the remaining side. So negative 3 squared plus 1 squared, 9 plus 1, which is 10, would equal c squared, which c then equals root 10. So that goes here. And then it told you that it was in quadrant 2. The reason it's in quadrant 2 is to tell you, this is where your all students take calculus comes into play, right? In quadrant 2, sine and cosecant are the only positive ones, which means when I go to find the remaining one, which, what did it ask for? Sine, right? Sine, I would know that it would be positive. And so I use the same triangle to get sine. I would do opposite over hypotenuse, 1 over root 10, and then rationalize it so that it's root 10 over 10. So eventually we're going to get to Pythagorean identities, but for now, use your right triangles. It's way easier. Other questions on that homework? Christian?
So for 80, you can just assume the smallest side is 1?
No, it's because it gave, so cotangent, right, means it's adjacent over opposite. And negative 3 by itself would be the same thing as negative 3 over 1. So the adjacent side got the negative 3. Because it's in that second quadrant, I would know that the x is negative when the y is positive. So that 1 would be the positive 1.
So if you would have done the rules of the special triangle, you would get that?
No, because this isn't a special triangle. You don't know anything about those angles. You only know those if you know that one of the acute angles is 30 or 45 or 60. Other than that, you don't know the relationship.
This is just a random triangle.
That's just a random triangle. Yep. Taylor.
So for 86, would you do the same thing? Like you would not use the trigonometric identities?
Oh, I lost 86. Where did 86 go? There. Yeah, let you see I crossed through it. We're not there yet. I mean, if you want to use it, it's just the sine squared plus the cosine squared equals 1. But we're not there yet.
Okay.
We haven't even talked about it. In my opinion, it confuses the heck out of people if you get to it before you need to. So that's next chapter. We get to do all those identities in chapter 5. So I would do the same thing. I would set up my triangle, find the missing side, use the location of the quadrant to figure out if it's positive or negative, and then find the trig functions.
I don't understand how sine is negative.
So negative 20 pi over 3 becomes negative 6 and 2/3 pi, right? If I switch that into coterminal, into mixed number. So the negatives just go the opposite way, but the even and odd rule is still the same. So negative 6 is still going to end up, so that would be negative 2, that would be negative 4. This is negative 6. I'm still going to end up on the right-hand side where all the other evens are. The difference is 2/3 from there. Negative means I'm going down and left. I'm going clockwise. So 2/3, because it's bigger than the half mark, I know it goes into the third quadrant. And then from there, my tangent and my cotangent are the only ones that are positive. So just make sure that if it's negative, you continue on in that. Once you figure out if it's left or right on the whole number, make sure you go clockwise if it's negative.
On the test, are we gonna have to graph all the way around?
No.
No? Okay, so
You do have to figure out where it is though.
Yeah, but so if it's negative, if it's odd number, we just look at the left side.
Correct.
And then we just go from there.
Yep. So if it was odd and positive, then I would start here and work my way this way. If it was odd and negative, then I would start at the same point, right? Except I would be going clockwise. So negative goes clockwise, positive goes counterclockwise. Questions on any of those 3 homeworks? So I'll go over 4, 5 tomorrow, which is your graphs of sine and cosine. But I want to get to that warm up and start 4, 6 today. All right, so all I did first is just go through and identify the A, the amplitude, the B, and the period to get a little bit of a head start. So number 1 says to find the amplitude, the period, and the graph. So the A was negative 3, the amplitude is 3, the B is 2 pi, which means the period is 1. What's the negative on the 3 due to this graph? It's going to flip it so that it's upside down. So there's a reflection here. I want to make sure at the end I remember to flip it so it goes upside down, okay? So from the period being 1, I know my key points would be that times a fourth times a half and 3/4, which means my first one is 0, my second one is 1/4, then 1/2, then 3/4, and then the last one is 1. So first key point when there's no phase shift is 0, and then the 1/4, 1/2, 3/4, the last key point is your period. So Tess is going to ask you to identify all that stuff. So then I draw on my curve. Mark my key points. So 0, 1/4, 1/2, 3/4, and 1. There's no phase shift or vertical shift, which means all I have to do is go off my amplitude and then make sure I flip it. If this is sine and my amplitude is 3, I would typically start at 0, go up to 3, down, so it would have typically looked like this. But because it is flipped, instead of going up to 3 first, I am going from 0 to -3 to 0, back up to +3, and back down to 1. So my curve looks like this. Raise your hand if you got it right. Okay, good. Questions on that one? Okay, 2. So A was 2. It's positive, so that's still my amplitude. B is now 2. The period is now 2 pi over 2, which is pi. And then multiply that times a fourth, a half, and 3/4. Then I would have gotten pi over 4, pi over 2, 3 pi over 2. The first one is 0. The last one is pi. So I go to my graph. Amplitude is 2. And my horizontal points are 0, pi over 4, pi over 2, 3 pi over 4. No, 3 pi over 2, sorry. And pi. That should be 3 pi over 3/4. This should be 3 pi over 4. Okay, and then it is just standard cosine. Cosine starts at your amplitude, goes down, down, up, up. So my graph would start at 2, go to 0, -2, 0, +2. My curve looks like that. And there's no phase shift. So if the question asked me to identify all the parts, I would just put that there's no phase shift. Make sure that when you're doing your homework and your practice that you are labeling those key points and showing the work for the stuff that requires the work. So if there's a phase shift, I should see the work to do it. Do not give me a blank graph with no key points and no work. You will not receive full credit. All right, number 3, amplitude, period, and graph. So now my amplitude, my A was 1, which is my amplitude. My B is 1, which means my period is 2 pi. And then my key points would have been 2 pi times a half times a quarter times a half times 3/4. This is my standard period. So I already know that that's pi over 2, pi, and 3 pi over 2. The first one would have been 0. The last one would have been 2 pi. This time there's a phase shift. So I either do the opposite of what follows x over what's attached to x, which would be pi over +1. Or I set what's inside the parentheses equal to 0. Solve it. Either way, I get that my phase shift is positive pi, which means to each of these 5 points, I am adding on pi. So I get pi, 3 pi over 2, 2 pi, 5 pi over 2, and 3 pi. And those are my new key points. So when I draw my graph, my first one should be my phase shift, which is pi, then 3 pi over 2, then 2 pi, then 5 pi over 2, and then 3 pi. And this would be sine. That would start at 0, go up to my amplitude. So if my amplitude is 1, it would have gone here, 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 here. It would have looked like this. But this time, this is the first one, so I added it in so that you could experience it. This is the first time that we've got one that has a vertical shift, and that vertical shift is in which direction? What happens when you add 1 onto a graph? Up 1. So all of these points get shifted up 1 spot. And that's my resulting graph. Okay. Again, test-wise, you can do one dashed and one dark. You can use colored pencils to distinguish the difference between the two, or you could just give me the one at the end. But you're going to see today when we get into reciprocal functions that you're going to want something that's got to be a little bit of shift. Christian?
The colored pencils, do we have to print them?
No, I have colored pencils. Nor. So the amplitude itself doesn't ever change. The 1 just means that from top to bottom would be double that, right? So that the vertical distance covered is still 2 units. The difference is where those units get shifted up and down. So the actual physical amplitude never changes by a shift, okay? It changes by the A. All right, then the last one, y equals -2 cosine x plus pi over 2. So now my A was -2, which means this is upside down. I'm going to remember to flip it at the end. The B is 1, 2 pi is your period. This time I have a phase shift. That is -pi over 2. So my period being 2 pi means I have my normal standard pi over 2, pi, 3 pi over 2. Started at 0, ended at 2 pi. And my phase shift, now I'm going to take those points and I'm going to subtract pi over 2 from each of those points. So my first point should be the phase shift, which is -pi over 2. Second one is 0. This is 2 pi over 2 minus pi over 2, or pi over 2. This would be 2 pi over 2, which becomes pi. And then this would be, oh, I'm missing the pi there. That would be 4 pi over 2, which is 3 pi over 2. Thank you. so now my horizontal points, my key points, would start at negative pi over 2. Sure.
Thank you. How did you understand that?
Alexis Pappas. So from here, again, my normal cosine, so before I flip it, my normal cosine with an amplitude of 2 would start at 2, go down to 0, down to negative 2, up to 0, and up to 2. It would have looked like this. But a negative on the front means it flips it upside down, so that I would start at negative 2, go up to 0, up to 2, 0, down to negative 2. And that one's your answer. You don't need both, but if you want to draw both, just make sure you distinguish the difference for me on your test. Questions overall. So be prepared for more than one shift. Obviously, you're not going to get just an amplitude change, okay? You're going to get an amplitude, a period shift, a phase shift, a vertical shift, a reflection, or a combination of those. All right, so I just want to get ahead of tomorrow. We're going to start 4-6 because it literally piggybacks on what we just talked about. So the order of the notes, I'm going to flip-flop, okay? Normally, the book's in the order of tangent first, and then goes to cotangent. We're going all the way to the reciprocal functions that are cosecant and secant. So I think this is slide 12, right? Something around there. So to graph cosecant and secant, I got it. You first have to graph their reciprocal function and then bounce your graph off of it. So if I zoom in on this, okay, this is cosecant, and cosecant's reciprocal function is what? Sine, okay? So if you see the little red dots, that is your standard sine curve, okay? It would have started at 0, it would have gone up to 1, back down to 0, back up to 1. So think about what happens every spot on the x-axis where this curve intersects it. What are those spots? Those become asymptotes. Why do they become asymptotes? What are they on sine? What's the value of sine at each of those spots? 0. What happens if I take 0 over 1 and I flip it? So all those points would typically be 0 if this was sine. If I flip it, because that's what we do to get the reciprocal, they now become undefined, right? 0 over 1 flipped is 1 over 0, which is undefined. And we've done these before. Anywhere there's an undefined spot on my graph, I usually do an asymptote. So that's where these asymptotes come from. Everywhere there would be a 0 on your parent function, there's an asymptote on your reciprocal function. And then every max, there's a parabola that bounces off of it going up, and every min, there's a parabola that bounces off of it going down. My expectation when you do graph these, when you graph them on your homework, when you graph them on your test, whatever that is I expect to see 4 asymptotes and 3 curves. That's going to be for all your reciprocal functions. So this is going to be for secant and cosecant, and also for tangent and cotangent. 4 asymptotes, 3 curves. But again, you start by graphing your reciprocal function. So if I'm going to graph cosecant, then I'm going to graph the sine graph first. And then everywhere there's an x-intercept, I draw an asymptote. And everywhere there's a max, I draw a parabola bouncing off to the top. Everywhere there's a min, I draw the parabola bouncing to the bottom. So we're going to just go through this. So then secant is the reciprocal of cosine, which means I do exactly the same thing, except my initial parent function is going to be cosine. So if you look at this graph, it starts at 1, goes down to 0, goes to negative 1, comes back up to 1. Again, everywhere there is a 0 on my cosine, there becomes an asymptote. And then every max has a parabola pointing upward, and every min has a parabola pointing downward. Same thing, 4 asymptotes, 3 curves. Example 1. This is just what happens if you shift things. So if I were to take my amplitude and I make it 2, like the one on the right, it's going to make my parabolas separate further. If on the left-hand side there's the x-intercept, oh no, that's the same thing. That would be your parent function. So the one on the left would be your regular sine, and the one on the right would be if the amplitude was 2 and there's an adjusted period on the right. So just examples of what it could look like. We're just going to work through one. So this says first graph y equals 2 sine x, or sorry, sine of 2x, then graph its reciprocal function. So it's kind of baby stepping you into there. On your test, it would say graph y equals cosecant 2x. And you have to know that that means you first have to graph sine of 2x and then add on the reciprocal function. So A is 1, which is your amplitude. B is 2, which means your period is 2 pi over 2 or pi. Your key points are at pi over 4, pi over 2, 3 pi over 4. First one at 0, last one at pi. Amplitude is 1, so I'm going up 1 and down 1. So my sine curve starts at 0, goes up to 1, down to 0, down to -1, up to 0. It would have looked like this. Everywhere there's a 0 gets an asymptote. How many asymptotes did I say you needed? 4. So you have an option. Do I want to extend this graph on to the right, or do I want to extend this graph to the left? I don't care which one, and you don't have to give me exact points there. Just make them equally spaced. So now there would be an asymptote here. So I'm doing 5 so that you can see what it would look like if you did left or right, but you only need 4. And then your parabolas bounce off your maxes and your mins. So that sine curve is actually technically not part of your graph. It's just how you get to your graph. Again, on the test, you have options. Either do the sine curve in something light and go darker on the actual cosecant curve, or do them in different colors, colored pencils. I don't care which way you distinguish the difference between them, but I should be able to tell the difference, okay? You need the first one to get to the second one, but you don't have to leave it there. You can either erase it or you can go back and make your answer darker, okay?